Today we will be talking about resonance and formal charge. Let's begin with resonance. Resonance is when there's more than one valid Lewis structure that is possible for a given molecule. Consider the molecule NO2, which has 18 valence electrons. Neither of the two structures shown represent the actual bonding in NO2 when looked at by themselves. The nitrite ion does not exist as either of these two extreme structures, but exists as an average of both. This means that the bond length for each NO bond will be 1 1/2 bond length, rather than having one single bond and one double bond. The thiocyanate ion also has resonance as shown through the three structures. Just like in the NO2 example, each molecule has brackets surrounding it with a charge on the outside. This is necessary for charged molecules. Resonance is represented through double-headed arrows. The arrows do not mean that the molecule flips from one resonance to another, but simply shows that the actual structure is an average of all of them. The concept of resonance is necessary because the localized electron theory states that electrons are localized between a pair of given atoms.
However, nature does not really operate this way.
In actuality, electrons are delocalized. They can move around the entire molecule. For example, the valence electrons in the NO2 molecule distribute themselves to provide equivalent NO bonds. Now on to formal charge. We can use formal charge to decide the most plausible structure from a set of resonance structures. Formal charge is the difference between the number of valence electrons on the free atom and that assigned in the molecule. We can use the formula formal charge equals the number of valence electrons minus the number of non-bonding electrons minus half of the number of bonding electrons to assign formal charge. Molecules try to achieve as low a formal charge as possible. In thiocyanate, there are three atoms: sulfur, carbon, and nitrogen. It is necessary to find the formal charge of each atom, so let's look at sulfur on the first structure. Sulfur has 6 valence electrons, 6 non-bonding electrons, and 2 bonding electrons. When plugging these values into the formula, you get formal charge equals 6 minus 6 in parentheses 2 divided by 2, which equals -1. The next atom, carbon, has 4 valence electrons, 0 non-bonding electrons, and 8 bonding electrons. The formula will be formal charge equals 4 minus 0 minus, in parentheses, 8 divided by 2, which equals 0. The final atom, nitrogen, has 5 valence electrons, 2 non-bonding electrons, and 6 bonding electrons. The formula will be formal charge equals 5 minus 2 minus, in parentheses, 6 divided by 2, which equals 0. There are important things to remember about formal charge. 1. Atoms in a molecule try to achieve formal charges as close to 0 as possible. 2. Any negative formal charges are expected to reside on the most electronegative atoms. 3. The sum of the formal charges of all atoms in a given molecule or ion must equal the overall charge on that species. Keeping these things in mind, try to work out the formal charge for each atom in the other 2 thiocyanate structures. You should have gotten the following values for each. The structure in the middle has a formal charge equal to the first structure. However, nitrogen is more electronegative than sulfur, so the negative charge should be on nitrogen, making the middle structure the most likely.
We hope that this video helped you review resonance structures and formal charge. Thank you for watching!